In the last lecture, we have started with numerical integration. Then we have seen the formulae for numerical integration. So, what we have trapezoidal rule. Okay. Then we have Simpson's rule. Okay. So, what the trapezoidal rule says, if we consider the interval from A to B and we want to integrate the integral. Okay, so what we have let I be the integral from A to B f of x dx, be the given integral. Okay, this we have to evaluate. Okay. So in trapezoidal rule, as we have seen, there is no restriction on the number of subintervals. Okay, so here we have considered n to be the number of subintervals. So there is no restriction. Now we have seen that for the Simpson's 1/3 rule. Okay, what we know for Simpson's 1/3 rule? What is the restriction? Anyone of you remember?
No restriction.
On Simpson's 1/3 rule.
N is even
number.
N is even.
N should be even number.
N should be even, right? So that's what we have. Okay, so for Simpson's 1/3 rule, we know that N should be even. For trapezoidal rule, there is no restriction. Okay, and then the third rule that we have seen. Okay, so we have Simpson's P8 rule. Okay, so what we have seen in the Simpson's P8 rule, what is the restriction we have?
N should be multiple of 3.
N should be multiple of 3. Is that true?
Yes, sir.
Okay, so here in trapezoidal rule, there is no restriction. No restriction on n, the number of subintervals. Okay, in Simpson's 1/3 rule, okay, n is even number. Okay, and in 3/8 rule, so what we have in 3/8 rule, n is multiple of 3. Okay, so these are the things that we need to understand and we need to remember while solving the problem. So for trapezoidal rule, we can choose the number of interval, whatever we want. Okay, in Simpson's 1/3 rule, we must have the restriction, or we must consider that n is going to be even number. The number of subintervals should be in even number, and 3/8 rule. So when we consider 3/8 rule, the number of subinterval must be multiple of 3. Okay. So now we have also seen the base choice. Okay. So what do we know about the base choice? The base choice is n is equal to 6. Okay. Why n is equal to 6? Because it is a multiple of 3 and it is a even number also. So if we consider the minimum number of subintervals that we should consider is 6. Yeah, we can consider more than 6 also, but then we have to consider multiple of 6 only, so that it will satisfy for all the rules. Okay, so minimum number that we should consider is number of interval equal to 6. Sometimes the number of interval is given, okay, but sometimes step size is also given. Okay, so what is the relation between the step size and the number of interval? Okay, so what we know is, we know step size h is equal to so it is xn minus x0 by n, or this is b minus a by n. Okay, so n is going to be the number of subintervals and h is going to be the step size. Okay, so if we know subintervals, we can calculate step size. If we know step size, we can calculate subintervals. Okay, so is there any doubt in these 3 formulae?
Sir,
Yes,
sir, this base choice will be only 6 or multiples of 6.
multiple of 6. 6 is a minimum. Base choice, that's why if you don't want to go for more calculations, okay, then 6 is the best choice. Okay, if you calculate, suppose, see, if you consider 12 as a number, so you have 12 subintervals. Okay, so your each interval will be chopped into 2 intervals.
Yes.
Okay, so minimum 6 is the best choice.
Yes.
Yes. Any other doubt? Is there any other doubt? If you don't have any doubt, yes?
No, sir.
Okay, that's good. So with this formula, now we'll try to go for the example. Okay, so we'll try to solve the example. Okay, so let's have the example. Are you able to see this?
Yes, sir. Yes, sir.
We have this example. A rocket is launched from the ground. Its acceleration is registered during the first 80 seconds, and the data recorded is given in the form of table. Now we have to find the velocity of the rocket at t is equal to 80 seconds. Okay, so what is the relation between the velocity and the acceleration?
dv by dt is acceleration.
Correct. Okay, so if the acceleration is derivative of the velocity, then what we can say, velocity is the integration.
Integral of acceleration.
Yes. Okay, so this we should know. Okay, so let us go with the solution. Okay, so let V be the velocity of rocket and A be the acceleration. So we have P is equal to, now we know we are starting, P is starting at 0 and up to 80, and we want to find the velocity at 80 seconds. So this is what will be. So V is equal to 0 to 80. A is equal A into 80. A is going to be acceleration. Okay. So is this formula okay? Are you getting this formula?
Yes, sir.
Yes.
Yes,
Okay.
sir.
Yes, that's good. So what is the given data? We have. Okay, it is given t seconds. Okay. And corresponding acceleration is given. So we have t in seconds and acceleration is meter per second square. Okay. So we have 0, 10, 20, 30, 40, 50, 60, 70, and 80. Okay. Right. So it is given 30 meters per second square, 31.63 meters per second square, 33.34 meter per second square, 35.47 meter per second square, 37.75 meter per second square, 40.33, 43.25, then this 46.69 and 50.67. Okay, so here this t is the independent variable, so this plays role of x, and a is the dependent variable, so this plays role of y. Okay, so if we consider, here we have x0, x1, x2, x3, x4, x5, x6, x7, and x8. So we can say here this is going to be y0, y1, y2, y3, y4, y5, y6.
So please scroll up a little.
Yes, y7 and y8. Okay, yeah. You can see now.
Yes, sir.
Yes. So we have to solve this problem using trapezoidal rule and using Simpson's 1/3 rule. Okay. So in this case, trapezoidal, we don't have any problem with the n number of subintervals. Simpsons, what should be the number of subintervals? Even, no?
Even.
Yes.
Even number.
So is that even here? How many subintervals we have here?
Yes, sir. Even.
Yes, it is even.
Yes, sir.
So it is going to be 8. Okay. Now, what is the value of h?
Sir, actually, there are 9 subintervals, right?
Is that true?
Yes, sir, it is 9.
We have 9 values. We have subintervals. Subintervals is x0, x1, x1, x2, x2, x3, x3, x4, x4, x5, x5, s6, x6, x7, x7, x8. So how many subintervals we have?
8.
8, sir.
8.
Even.
Is that okay?
Yes, sir. I got it.
Are you getting this? Or otherwise, we think like this. So x1 to xz. This is x0, x1. So this is the first subinterval. Okay, x1 to x2. This is second subinterval, and so on. We have 8 subintervals. Are you getting this?
Yes, sir, I got it.
Yes. Okay. So now we need to have H. Okay. So we know that there are 8 subintervals. The number is even. So we can apply the Simpson's 1/3 rule. Okay. Now see, we have H is equal to, what is H? H is xi minus xi minus 1. Okay, so in general, H is equal to xi minus xi minus 1. Okay, so you can see this is the equally spaced data, correct? So can you guess what is the value of H?
10.
10. H is going to be 10 and N is going to be 8. Okay, so what do we have? H is 10 and N is equal to 8. Okay, now we want to find the value of this velocity using trapezoidal rule. Okay, so what we can do the next? We can consider trapezoidal rule. So what this trapezoidal rule says, I is equal to, but here what is I? I is going to be V. So velocity is equal to, will be h by 2. Okay, and what do you know? X plus 2r, right? So where x is equal to extreme terms and r is equal to, and r is equal to remaining all terms. Is that okay? So we have hence V is equal to, so H is going to be 10 by 2. Okay, are you getting this formula? This we have written here. Okay, so we can see this trapezoidal rule. Okay, so you can see this trapezoidal rule, h by 2 x plus 2r. Okay, and so here extreme means n terms and remaining all terms. Okay, so capital X is for the extreme terms. Now here we have to consider the values of y. Okay, so we have to be careful. This is equal to, let's have the extreme term first. Extreme term means y0 and yn. So it is going to be 30 plus 50.67. This is our x plus 2 times. Now remaining all terms. So we can have 31.63 plus 33.34 plus 35.47 plus 37.75 plus 40.33 plus you can have 43.25 and plus 46.69. So this is what we have. Now we have to calculate this value. So what is the value you are getting for this?
Sir, I'm getting the value of V 3087.95.
That 3087, 3000 and
3087.95.
3087.95. Okay, let's think of the others. What about the others? What are the value you are getting?
Yes, sir, same value.
Same value?
Yes,
Okay,
sir.
so it is 3087.95 and this is meter per second. Okay, because velocity we measure in meter per second. Okay, so we can say here, hence the velocity of rocket after 80 seconds is 3087.95 meter per second. Okay, so this way we are able to calculate the velocity of the rocket as we have recorded acceleration. Yeah, so we have recorded acceleration, then we calculated the velocity. Okay, and if we calculate, if we record the velocity at every point, we can find again the distance covered by the rocket in 80 seconds. Okay, so if I calculate the velocity at 0, it will be 0. At 10, we can calculate. At 20, we can calculate. At 30, we can calculate. So on. And then we can, after getting the value of this velocity after each 10 seconds, if we again integrate, we are able to get the distance covered by this rocket in 80 seconds. Okay. So now, this we have calculated by using the trapezoidal rule. Okay, we have to use the Simpson's 1/3 rule and verify that how close we are. Okay, so verify that how close we are. So now let us try to find the value of this velocity. Okay, so this we got by trapezoidal rule. Okay, now we consider Simpson's 1/3 rule. Okay, so we have what we have V is equal to. Okay, so 1/3 rule, it will be h by 3. Then we have x plus 4o e. Okay, so we hope this is correct. Okay, so you can see this is going to be 4o and 2e. Okay, so what this x, o, and e says, so this is going to be, okay, I'll write here. Okay. So this is 4 times o and 2 times e, where x is equal to, again we have extreme terms, o is equal to odd terms, and e is equal to even terms. Okay, and hence we can write here. So we get, what we are able to get is v is equal to 10 by 3, and this is 30 plus 50 point. Okay, so we have to scroll up and then get these values from here. Okay, so it is going to be 50.67. Okay, so it's going to be 50.67. Then plus 4 times odd terms. Okay, so odd terms you have, these are the odd terms. So y1, y3, y5, and y7. Okay, these are the odd terms. So let's have this 31.63. Okay. So this is 31.63 plus, and now 35.47, 35.47 plus, we have 40.33, 40.33, and then we have 46.69. So this is 46.69 plus 2 times E1. Okay, so what is 2 times E1? So we have 33.34, 33.34 plus we have here next 37.75, 37.75. Next, what we have 43.25 plus 43.25. This is what I have. So we get V is equal to, what is the value of V you are able to get here? Will be near by
3086.1.
3088.1.
88.1, 3086.1,
3086.1.
3086.1. Okay, so we get here 3086.1, and this is meter per second. Okay, so its velocity, it will be meter per second. So we got here, see the previous value that we have got is 3087.95, and here we got is 3086.1. Okay, so we can say hence velocity okay after 80 seconds is 3086.1 meter per second by Simpson's 1/3. Okay, so by using Simpson's 1/3 rule, we are able to get the value of velocity to be this one. And by using the trapezoidal rule, the velocity estimated is this one. So this way, we are able to use the Simpson's 1/3 rule and the trapezoidal rule to find the value of integral or the required value. So is there any doubt in this example? Is there any doubt in this example?
No, sir.
No, sir.
No, sir.
Okay, that's good. So I hope all of you are able to get this. Good. So this way we use the Simpson's 1/3 rule and the trapezoidal rule. So here we have seen, while using the Simpson's 1/3 rule, we must have the number of subintervals to be even. Okay, so let us think of the next example. Okay, so we go for the next example. The depth of the viewer is recorded as below. find the area of cross section using trapezoidal rule, Simpson's third rule, and Simpson's create rule. So here the data is given. Distance from one bank and depth. So distance is in meter. This depth is also in meter. Okay, so this is distance from one bank, and this is depth in meter. Okay. The distance is measured in meters. Bank. Okay. So here we have to use all the rules together. So we have to use trapezoidal rule. We have to use Simpson's 1/3 rule. Also, we have to use the Simpson's 3/8 rule. So first of all, we need to check whether our conditions are satisfied or not. So we can say consider the given table. Distance from one bank river and the depth of river. So we have what we can have is going to be distance. Distance and depth. 0, 10, 20, 30, 50, 60. Okay, this is 0, 5, 10, 15, 17, 12, and okay. So here we have the depth and the distance. So how this will look like? See, this is the sea level or the level, and then from one bank we are starting, and it is like this. So here we have 0, here we have 60. Okay, and at 10 is going to be 5 meter at 10, 20, 30, 40. So at 10 it is going to be 5 meters, at 20 it is going to be 10 meters, at 30 it is going to be 15 meters, at 40 it will be 17, at 50 it will be 12, and at 60 again it is going to be 0. So we have to find this area of cross section. So actually this is the inverted system. Okay, so how do we see, or we can see this as, if I consider the mirror image of this, then it will be like this. Okay, so this is going to be 5, this is 10, this is 15, this is 17, it's going to be 12, and 0 and 0. So this is 0, 10, 20, 30, 40, 50, and 60. Now we have to find this area. So this is our actual problem, but the mathematical similar mathematical model says that this can be like this also. Okay, so this is the mathematical model. This is the actual problem. Now we want to find the area. That means what we have to do is we have to use the trapezoidal rule, Simpson's 1/3 rule, and then Simpson's 3/8 rule. So we have, this is x0, this is x1, x2, x3, x4, x5, and x6. Okay, so this is y0, y1, y2, y3, y4, y5, and y6. Okay, so check whether the conditions are favorable to us or not. So see the number of subintervals. What we have? We have h is equal to, what is the value of h here?
10.
10. Okay, and what is the value of n here?
6.
6.
6.
So is this condition favorable to apply all the rules?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so that's why I have told you that best choice is going to be 6. Okay, and it is given 6, so we don't have any problem. Okay, so we have to, we can apply all the rules. Okay, and hence what we can see by trapezoidal rule, the area A of cross section B1 is given as. So what will be area? A is equal to, it will be h by 2 x plus 2r. Okay, where x is equal to extreme terms and r is equal to remaining all terms. Okay, so whenever we are using any notation, okay, so we must explain that notation also, what that means. Okay, because x is coming in all the formulas, r is coming in all the formulas, r is coming in 2 formulas, not in the Simpson's 1/3. Okay, so here what we can have is a is equal to, so this a is 10 by 2 extreme terms, so it is 0 plus 0. We can see that, see, y0 is 0 and y6 is going to be 0. So now what we have to do is we have to consider all these terms remaining. So 5, 10, 15. So it is going to be 5 plus 10 plus 15 plus 17 plus 12. Is that okay? Okay, these are the remaining all terms. The end terms are 0. Okay, because the depth of the bank is going to be 0. Okay, so this is the bank of the river, this is the bank of the river. So the depth at the bank is going to be 0. Okay, so tell me what is the value, what is the area of cross section you are getting? So A is equal to
Eight 35.
what is that?
590.
590.
Yeah,
Yes, sir. 590.
590.
Yes, sir,
590.
590.
Meter square.
Okay, this is what you are getting.
Yes, sir.
Yes, sir.
Okay, so this is
Yes, sir.
590 meter square, right? We have measured this in meter, no? So that's why it will be meter square. So it is 590 meter square by trapezoidal rule. Okay, so we got this value by using trapezoidal rule. Okay, so now we have to think of the next. Now we consider Simpson's 1/3 rule. So what is Simpson's 1/3 rule says? A is equal to, it will be h by 3, x plus 4 odd plus 2 even. Okay, so 4 odd plus 2 even, where x is equal to extreme terms, O is equal to odd terms, and E is equal to even terms. Okay, so that's what we have. Now, let's have this. So we get here A is equal to, this will be 10 by 3. O plus O plus 0 plus, this is going to be 0 plus 0. This is going to be 4 odd. Okay, so what are
Sir, can you
the,
please scroll up a little?
yes. Okay, so what are the odd terms you have? So this is, these are the odd terms we have. Okay, so y1, y3, and y5. Okay, so it is 5, 15, and 12. It is going to be 5, 5, 15, and 12 plus 2 even. So what is 2 even? It is going to be 10 and 17. Okay, so that's what we have here. So this is going to be 10 by 2 and 17 by 4. By 6 is already calculated as an extreme term. So that's what we get here. Now tell me what is the value of A?
606.76.
6.67.
60.67.
6.67.
Correct. Okay, and this will be meter square. So the area of section A is 606.67 meters square by Simpson's 1/3. Okay. So now we have Simpson's 3/8 rule as. So what is the Simpson's 3/8 rule? So it is going to be A is equal to PH by 8. So it is going to be X plus, okay, dt plus 2R. Okay, is that okay? So here we have this 2t plus 3r. Okay. So we have 2t plus 3r. Be careful. This is 2t plus 3r. Okay. Where x is equal to extreme terms. E is equal to multiple and R is equal to meaning okay. So here what we are going to get, A is equal to 3 into 10 by 8. Okay. Extreme terms 0 plus 0 times multiple of 3. So what will be the terms multiple of 3 here? What is the term multiple of 3?
Y3 only.
It will be only y3 because y0 already we have considered, y6 already we have considered. So it will be y3 only. And if I say y3, the value of y3 is 15 plus 3 times r. So it is going to be 5. So it will be 5 plus 10 plus 17 plus 12. Okay, that's what we. So now tell me what is the value you are getting? For this calculation?
607.5.
607.5.
7.5. So it is going to be meters square. Okay. We can have hence the area of section A is 607.5 meters square by Simpson's 8 rule. So here we got the values. Okay. So by Simpson's 8 rule, the value is 607.5. By Simpson's 1/3 rule is 606.67, and by trapezoidal rule it is going to be 590 meters square. Okay, so this way we can see that as we go for more number of intervals, okay, or more refinement of intervals, then we are able to get the better results. Okay, so is any doubt in this example? Is there any doubt? All of you got this example?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so here we have solved the example using the trapezoidal rule, using the Simpson's 1/3 rule, as well as using the Simpson's 3/8 rule. Okay. So we'll go for the next example now. I hope you are able to see this. So using the 3 different rules, we are able to calculate the numerical value of the integration. So let's go for the another example.
So
Yes.
the values which we got by 3 methods are quite different. So which is more accurate?
Yes. We cannot say quite different. They are nearby. Okay. So as this we are approximating. Okay. So we can see here the area that we are finding, this is not a smooth curve. Okay, so if it is a smooth curve, we'll exactly get the value by integrating. Okay, if it is not the smooth curve, then we are not able to get the exact value by integrating. And that's why we are trying to find what is the approximate value. Okay, so if this curve is defined by some functions, for example, it is x square. Okay, so x square is an integrable. So we can integrate x square and we can find the value, or we can find the area under this curve. Okay, but in this case, this curve is not exactly defined. Okay, and hence we are approximating. And actually, what we are doing is we are approximating this by the trapezium. So you can see this is a parallel line. Okay, and this is going to be a trapezium. Are you getting this? So that's why the first rule is called as trapezoidal rule. Okay, in Simpson's one-third rule, this trapezium is divided into two sub-intervals. Okay, and that's why the number of sub-intervals in the Simpson's one-third rule is a multiple of 2, that is even. And then in Simpson's 3/8 rule, we divide this same trapezium into 3 smaller trapeziums. Okay, and that's why the number of subintervals become multiple of 3. Okay, and this is how the restriction on number of subintervals in the Simpson's 3/8 rule is multiple of 3. Okay, so here, if this is the area that I want to evaluate, okay, so this curve will draw. This is not the smooth curve. Okay, so this curve is actually like this. Okay, and when we try to approximate, so we try to approximate this by using a trapezium. So here you can see some area we have missed, and here you can see some area we have calculated more. Okay, so that's why our value by using all these 3 different rules will be an approximate value. Okay, so we can claim that the value calculated by Simpson's 3/8 rule will be more accurate. Got this one?
Yes, sir.
Sir,
Yes,
I had a doubt here.
yes, please.
So, sir, we have this table. So by using Newton forward difference or backward difference, we can get a function. And if we integrate that function, will the answer be the same?
Again, that function, whatever we are getting, that is approximating polynomial.
Yes, sir.
Okay, so again, that is going to be approximating polynomial. Okay, so actual value or exact value we will not able to get.
But approximate, we will get it the same, right?
Yeah, what is the use of forward difference formula and backward difference formula?
Interpolation.
Interpolation or extrapolation. That means we find the missing value.
Yes, sir.
Okay, we find the missing value. Here we are not finding the missing value. We are adding all the values. Got it?
Yes, sir. Got it.
So by interpolation, okay, what I can do by interpolation? By interpolation, I can find what is the depth at 25 meters. Got it?
Yes, sir.
By using the interpolation, Newton's forward difference formula or backward difference formula, we can get what is the depth at the 25 meters. Okay, but we will not able to find the area. We will find the polynomial which will approximate this, and then you want to integrate that polynomial, right? Correct?
Yes, sir. That
Yes, but the purpose of that polynomial is to find the missing value or to predict the value. Okay, so your approach is correct. Okay, but that technique will also give you the approximate value, not the accurate one. So that value will be nearby this value. We cannot claim that we will get the same value.
okay, sir. Understood.
Okay. So is there any other doubt?
Sir, I did not understand that why n is here a best choice. We can take 8 also.
Very good. Okay. So if I choose n is equal to 8, right? Is that okay? Suppose we choose n is equal to 8, right? What is the restriction on n in Simpson's 3-8 rule? How many subintervals we want in 3-8 rule?
Multiple of 3.
Multiple of 3. Is 8 multiple of 3?
No, sir.
No, sir.
No. So that means we cannot have n is equal to 8 as a base choice. So n is equal to 8 will be good for trapezoidal rule and Simpson's 1/3 rule, but not for the Simpson's 3-8 rule. So Simpson's 3-8 rule will not be applicable if we have n is equal to 8. Got this one?
But sir, we have remaining r na, in that equation. So we can put that remaining 2 in that r.
No. We must have the number of subintervals to be multiple of 3. And just now I explained why it is a multiple of 3. Okay. So in Simpson, in trapezoidal rule, we consider one trapezium. In Simpson's 1/3 rule, we divide that same trapezium into 2 parts. So the number of interval becomes multiple of 2. And in Simpson's 3-8 rule, we divide the trapezium into 3 parts. So the number of interval becomes multiple of 3. So for Simpson's 3-8 rule, we cannot have any number n is equal to which is not a multiple of 3. Got it?
Okay, sir. Yes.
Yes.
Okay, very good. Okay, so can we go for the next example?
Yes, sir.
Yes. Okay, so let us go for the next example. So here it is said that evaluate this integral 0 to 6 dx 1 plus upon 1 plus x square by using all these 3 rules. Okay, so the interval is not given and the number of sub-interval is also not given and the table is also not given. Okay, so what we'll be having, like I is equal to. So what we have, I is equal to integral 0 to 6. Okay, dx upon 1 plus x square. T, the given integral. So here we have to decide the number of subintervals. How many number of subintervals you want?
6.
6 is the base choice. Okay, so you can have 12. See, we have to use Simpson's 3-8 rule and Simpson's 1/3 rule. That means it is a multiple of 3 and 2 at the same time. So LCM of 3 and 2, which is going to be 6. Yeah, we can have the many multiples of 2 and 3 together. Okay, but the minimum is going to be 6. So here we consider n is equal to 6. So what is A is 0, B is 6, and hence H is equal to, what is H? B minus A by n. So what we have here is going to be 6 by 6, and that is going to be 1. So we got here H is equal to 1. So when we consider the number of subintervals used to be 6, then the length or the size of each interval will be 1. Okay. Now, once we know the size of the interval, we are able to construct the table. So consider the table. Okay. So what is the table will be having?
Sir, it must be X and Y.
Yes. So it is going to be x. But what is y here? Y is 1 upon 1 plus x square. This is the
Yes.
function that we have to consider. Okay. And the values are 0, 1, 2, 3, 4, 5, and 6. Okay. So if we consider x is equal to 0, so this term is going to be 0, this term is 0, so it is going to be 1. So if I consider 1, it is going to be half. Okay. Or we can write this as 0.5. So this is going to be 0.5. Now if I put x is equal to 2, so it will be 1 by 5, and that is going to be 0.2. If I put x is equal to 3, so that is 1 by 10. So we can have this is going to be 0.1. If I put this is going to be 4, so this will be 1 by 17. So what is the value of 1 by 17?
0.06.
0.06. Some more digits.
Sir, 0.0588.
0.0588. Right? Okay. So we consider 4 digits. That's okay. If I put 5, then this will be 25 and 126. So 1 by 26. So it will be 0. What do you have here?
0385.
0385. If I put 6, then it will be 1 by 37. So we got here
0.027.
27.
0.
0. Okay. So this is the table that we have constructed. Okay, and hence what will you have here? X0, X1, X2, X3, X4, X5, X6. Okay, so you can mark this by pencil also. So Y0, Y1, Y2, Y3, Y4, Y5, and Y6. We know the odd terms, even terms. Okay. So now first we'll consider this value by trapezoidal rule. Okay. So let's have the value by trapezoidal rule, and hence we can say by trapezoidal rule we have. Okay. So what is the value of I? So it is h by 2, and then we have x plus 2. Okay, where x is equal to extreme terms. And r is equal to remaining all terms. Okay. Now let's calculate this. Okay, so we have hence we get. So what we are able to get is h is going to be 1, so it will be 1 by 2. Okay, extreme terms, so it is 1 plus 0.0270. The initial term and the last term. Okay, plus 2 times r. So it is going to be 0.5 plus 0.2 plus 0.1 plus 0.0588 plus 0.0385. Okay, and so we are able to get the value of I. So tell me what is the value of I we get?
1.2108.
1.21.
Sir, I am
1.4108.
getting 1.41
1.4108.
1.4108.
08.
Yes, sir.
So
1.4108.
what about the others?
Yes, sir.
Are you getting the same?
Yes, sir.
It is 1.4108 that will accept. Okay, because most of you are getting this. Okay, so we got the value by trapezoidal rule. Okay, so let us think of the next. So consider Simpson's 1/3 rule. We have. So what is the Simpson's 1/3 rule says? So I is equal to h by 3, x plus 4 odd plus 2 even. Okay. So that's what we have, where x is equal to extreme terms. O is for odd terms and A is for even terms. Okay. So here we get, so what we are able to get, I is equal to, h is going to be 1, so this will be 1 by 3. Extreme terms, 1 plus 0.0270 plus 4 times odd terms. Okay, so what are the odd terms? 0.5, 0.1. Okay, so we got here is going to be 0.5, 0.1 and 0.0385. Okay, plus 2 times even term. So it is going to be 0.2. Okay, plus we have 0.0588. So is that okay? Are you getting these values? See here from the table. That's why you should name the terms so that it will be easy for you to understand. So this is y1, this is y3, and this is y5, which are odd terms. Okay, even terms. This is y2 and y4. Okay, so these are the even terms. So we got here the odd and even terms, and hence we can write the value of I. What is the value of I you are getting here?
1.3662.
1.3662. Is that okay?
Yes, sir.
Others, please confirm this value.
Yes, sir.
Yes,
Yes,
sir,
sir.
same.
Okay, because we are getting here 1.4108. Okay, so this is by Simpson's 1/3 rule. Okay, now we have Simpson's 8. So what we have 3/8 rule, I is equal to pH by 8, and we can have x plus 2t plus 3r. Okay, so where x is equal to extreme terms, p is for multiple of 3 and r for meaning all. Okay, so we get here I is equal to p by 8 extreme terms 1 plus 0.0270 plus 2 times multiple of 3. So what is going to be multiple of 3? Is it y3.2? We can see the table y3 is 0.1. Okay, so this is going to be 0.1 plus 3 times R. So it's 0.5 plus 0.2 plus you can have this is 0.0385 plus 0.0588 plus 0.0384. Okay, so what these values? Yep. We got all the values. Yes. So we are able to calculate this value now. So we get I is equal to what we are getting
1.35708.
1.3571.
3571.
Okay. Is there any other value you are getting apart from this?
No, sir.
All of you are getting the same value. All of you are getting the same value.
Sir, can you show the previous method, Simpson's
Yes.
1/3 method?
Yes, sure. Okay, this is what we have, Simpson's 1/3 rule. All of you got this? Is there any doubt in this example?
No doubts.
Oh, that's good. Okay. Now we can go for another example. Are you able to see this? Okay, so we have to use Simpson's 1/3 rule to find this integral by taking, and it should be only some dx, by taking, it should be by taking 7 ordinates. Okay, 7 ordinates means what? We have to take the 7 values here from 0 to 0.6. So that means we have to take the 6 intervals. Okay, so this we need to understand. So we go with the solution. What we can have? Okay, I'll add this. Also evaluate using trapezoidal rule. Okay, so let I is equal to the integral 0 to 0.6 e raised to minus x square. Okay, dx d given integral. So we have y is equal to e raised to minus x square, or we can say 1 upon e raised to x square. Is that okay? Are you getting this?
Yes.
Yes. Okay, so consider n is equal to 6. Okay, because we want 7 ordinates, that means we must have the 6 subintervals, and hence h is equal to. So what will be having 0.6 by 6, and that's going to be 0.1. So we got h is equal to. So we have n, we have h, we can construct the table as we know y also. Okay, so let us construct the table. Okay. So we have the following table. Okay. So what is the table we'll be having here? See, this is going to be X and Y. So here we have X and this is Y, which is 1 upon e raised to X square. Okay, so we have 0, 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6. So here we have to calculate these values x0, x1, x2, x3, x4, x5, and x6. So we can have y0, y1, y2, y3, y4, y5, and y6. Now you can type this directly in your calculator and evaluate the value of this function. Okay, so you can directly also make the table, okay, using these values. So give me the table if you can directly.
Sir,
Yes.
so can you scroll down a little?
Yeah.
Thank you, sir.
Yes. So please calculate the table. You can calculate it by using the calculator directly. What will be the value of y if we put x is equal to 0?
1.
1. What will be for this term?
0.819.
0.819. One more digit.
So it is 0.8188. 87.
188. Okay.
Yeah. 0.8187.
87 or 81?
87.
87.
Okay, 87. What about this?
0.6703.
6702. Okay.
03, sir.
3.
03. Okay. This will be
0.5488.
5488.
0.4493.
0.4493.
0.3678.
3678.
0.3011.
3011. Okay, so that's what we can have. Okay. Now we know we have to find this integral using the Simpson's one-third rule and trapezoidal rule. So first we'll go with the trapezoidal rule. Okay. Consider trapezoidal rule. Big 8. So what we have, I is equal to h by 2 x plus 2r, where x is equal to extreme terms and r is equal to remaining all terms. So I is equal to, what is the value of h? H is 0.1 by 2. So this is x 1 plus 0.3011 plus 2 times r 0.8187.
Sir,
Yes.
sir, I'm getting y1 as 0.99.
Yes.
sir.
Same.
Yes, sir.
Yes, sir.
So
Same.
getting
Yes.
0.9.
Yes, sir.
Yes,
Do you-
sir.
Yes, sir.
Sir, I am getting completely different values for every
Yes, sir.
y
All are
term.
different, sir.
Sir, I am also getting.
You only calculated this values, no?
Other one, sir. Not us.
So that's why I asked you to calculate the values carefully. Okay, what is the value you are getting for 0.1?
So 0.9
0.99.
0.99.
00.
Are you sure?
Yes, sir.
Yes, sir.
Okay, let me check. Just after calculation, you will say that this is different. Okay, so I hope able to calculate this. So what are the values you are getting now? 0.9900. Okay,
Sir, 0.9607,
9607,
0.9139,
9139,
0.8521,
21,
So double seven.
0.7788, 0.6977.
six. Okay. So that are the values we are getting, right? Okay. Now, yes.
Sir, actually, I told you, I told you before values. Sir, actually, I changed my calci also, but how can I get different values now?
You need to set your calculator properly. Okay. So if it is set in some other mode, then it will create a problem. Okay.
Okay, okay.
So check the settings of your calculator because I am getting these values now as I have calculated. Okay. So that's why I calculated it. And now what we have here, this will be 0.6976. Then 2 times 0.9900 plus 0.9607 plus 0.9139 plus 0.8521.
Sir,
And
why are
plus,
we using this method? The question asked us to use the Simpson's 1/3 rule.
oh, you didn't see the question then that I have extended to use the trapezoidal
Okay,
rule
okay,
also.
okay. Sorry, sir. Sorry, sir. I missed it.
Yeah. Okay. So that's what we have. Okay. Now tell me what is the value of I? We get I is equal to
0.53445.
0.53.
445.
Okay. What about the others?
I'm getting 1.883.
0.88.
I'm getting 0.
So 0.4644.
0.46.
44.
Sir, I'm getting 0.5354.
5354. So any different answers for the same calculation?
Sir, mine's wrong, sir. I made a mistake, sir. 1.8 is wrong, sir.
Okay, now out of these three values, which is correct one?
Sir, I'm getting 0.
So 0.534.
0.5344.
0.534.
Okay, so I hope now you are not
0.534.
you are not committing any kind of error. So we accept that 0.5344 is the correct one. Okay, as most of you are getting the same. Okay, so here we have to be very careful. Okay, what value we are getting and how the calculations we are doing. Because if you miss one value, and then your answer will be missed. Okay, so now we have Simpson's 1/3 big 8. So what we are able to get here, I is equal to, what is in the 1/3 rule? H by 3, x plus 4 odd plus 2 even. Okay, so that's what we have. Where x means extreme values, then O means odd terms, can make it terms, and then E for even terms. Okay, so we have, what we can have here, I is equal to 0.1 by 3. Okay, and this is 1 plus 0.6967. Okay, plus 4 times odd. Okay, so what will be having odd? 0.9900 plus 0.9139 plus 0.7788. Okay, and 2 even. Okay, so what we can have here is going to be 0.9607 plus 0.8521. Is that okay? So these are the even terms and odd terms. Now we are able to calculate this. So calculate this value. Now remember, this will be nearby to this value. It will not be too different.
0.5351.
0.5351. Okay, this is the value. Is there anyone who is getting different than this?
No, sir, same values.
Sir, I'm
Yes.
same values.
You are getting same value, no?
Yes.
Sir, yes, sir, same value.
Okay, that's good. Okay, so all of you are getting the same value. That's good. So is there any doubt in this example? Is there any doubt in this example?
No, sir.
No doubt, sir.
Okay, that's good. Okay, so this way we are able to use the formula, that is the Simpson's 1/3 rule, Simpson's 3/8 rule, and we are able to use the trapezoidal rule. So using these three rules, these are commonly used rules for numerical integration. Okay, so there depends on the number of intervals. If you consider more number of intervals, okay, then we have the different rules like Wedley's rule and so on. Okay, so basically, if we want to find the numerical value of the integration easily, so these are the three rules. And the important thing is that the number of subintervals that we should consider to be 6. Okay, so you have to understand this. Why 6? Because it is the LCM of 1, 2, and 3. Okay, so we don't have any restriction on trapezoidal rule. We want an even number in Simpson's 1/3 rule, and we want a multiple of 3 in Simpson's 3/8 rule. And that's why we have chosen the base choice to be 6. Okay, so I hope you will able to solve the problems based on this 3 rules now.
Yes, sir.
Yes, sir.
Okay, that's good.